Hello everyone. Today we're going to be continuing with the questions of the June examination 2021 done in the Northern Cape. Okay, so now we're going to question 5. Last time we did question 4. Now we're going to do question 5. Question 5 is related to Doppler effect. Okay, so let's go through the question and then we'll see what happened. The question says the siren of a police car emits sound wave of frequency of 620 Hz. This is the frequency of the source. Remember, in Doppler effect, you have an object which is the source. In other words, it's the one producing the sound, and you have a listener, which is the object that is receiving the sound, okay, or the sound wave. So this is the frequency of the source. Stationary mean that the velocity of the listener is equal to 0. The mean will be the listener, okay. So we're going back. The siren of a police car emits sound wave of frequency 620 Hz. A stationary man sees the police car approaching him at constant velocity on a straight road and notice that the frequency of the sounds change. The speed of the car is 30 meters per second. This will be the speed of the source, and that is equal to 30 meters per second. Assume that the speed of sound in the air is 340 meters per second. This is going to be the speed of sound in the air. Speed of sound. All right? So that is the question. We already did take out the important information, the data. Let's start answering the question. All right? Now, 5.1 says state the Doppler effect in words. So let's go to solution. Solution 5.1 Doppler effect in word. So what is Doppler effect? What is Doppler effect? Doppler effect is the change in frequency, let me just fix that word, is the change in frequency of sound detected by a listener detected by a listener because the sound source and the listener have different, let's go to the next line here, have different velocities relative to the medium of sound propagation. So let's read again. Doppler effect is a change in frequency. Now, that change in frequency is very, very important, right? Change in frequency is very important. It's a change in frequency frequency of sound detected by the listener because the sound source and the listener, and this is important, sound source and listener have different velocities relative to the medium of sound propagation. Now, this question, which is the definition of Doppler effect, will have carry 2 marks. And please make sure you learn the definitions because it is very, very important. All right, let's go to 5.2. Now 5.2 said calculate the frequency of sound wave detected by the stationary man. It's 5.2. 5.2. All right, now To do this question, we have to apply the formula. Let's go to the control test, and let's go to the formulas at the end. The formulas are given, so you don't have to learn the formula by memory. Here you can see wave sounds and light. Here will be the part of Doppler effect. So you can see the general formula there. This is the general formula for Doppler effect. There is another formula for other topic you're going to do later on, but the Doppler effect general formula is there. So we're going to write it exactly as it is in there. All right. So this formula, I'm going to write it with this color. Say that the frequency of the listener will be equal to the speed of sound plus minus speed of the listener divided by the speed of sound plus minus the speed of the source, everything multiplied by the frequency of the source. So that is the general formula, and you will get 1 mark for that general formula. Now we have here different scenarios. Okay, so let's look at the scenarios real quick. Okay. We have different scenarios. Now, the good thing is always, if the listener is moving, the source is going to be at rest. If the source is moving, then the listener is going to be at rest. So let's look at this different scenario. We have only 4 scenarios. The first one is when the source is moving away. Source is moving away, therefore the listener will be at rest. Then the speed of sound will be plus the speed of the source. We're talking about this part here at the bottom. All right. Second scenario, is when the source is moving toward. It's moving toward. Therefore, the speed of the source of the sound, will be minus the speed of the source. Let's look for another scenario. Now, the other scenario will be when the listener moving toward. Moving towards. Then will be speed of sound plus speed of the listener. And the last scenario will be when the listener is moving away. And then in this situation will be speed of sound plus minus, minus the speed of the listener. Those are the 4 scenarios that you have to apply into this formula. So let's quickly do the substitution. All right, let's do the substitution, but before, let's go back to the question to see who is moving. Remember, we mark here the listener is stationary, so the one that is moving is the source. The siren of a police car emits sounds of wave frequency 320. Okay, stationary man sees the police car approaching, so the source is moving towards. So if it's moving toward, source moving toward, this is the scenario we are going to be dealing with. This is the scenario we're going to be dealing with. Okay, so this will be frequency of the listener is equal to the speed of sound plus minus speed of the listener, but the listener is not moving. All right, divided by speed of sound plus minus speed of source. Here is the scenario we're using. So it's speed of sound minus the speed of the source. That is the scenario we're going to use multiplied by the frequency of the source. That is the scenario we're using. I recommend you to learn these ones. I think you don't have to learn all of them. You can learn, for instance, this one, and obviously the other one will be the other way around, the opposite. However, I recommend you to learn. You do have to learn those. So if we do the substitution, the frequency of the listener is equal to speed of sound. Let's use the data here. So we see the speed of sound is 340 meters per second. So this is equal to 340 meters per second divided by 340 minus speed of the source. Let's go back to the question again. Speed of the source is 30 meters per second. So minus 30 meters per second multiplied by the frequency of the source, which was at the beginning of the question, is 620 hertz. You can see it right there, 620. So all we have left is to do the calculation. So the calculation is easy. It's 340 divided by 340 minus 30, right? Which is 310. So the calculation will be 340 divided by 310, and that will be multiplied by 620. So the answer is 679,999, which is 680. We can leave it in 680. So the detected by the listener is 680 Hertz. This is the answer for this question. Now let's look quickly at the mark allocation. The mark allocation will be 1 for the formula, 1 for the entire substitution, 1 for the final answer, and that gives us 3 marks. Alright, so let's go to the next question. The next question is 5.3. 5.3. Now, question 5.3 said, explain why the frequency of the sound detected by the man is higher than the sound emitted by the siren. Now, what is happening? And let's not get confused. When the source is moving toward, as the source moving toward, it is compressing the wave. So the wavelengths will come smaller. And therefore, due to become smaller the wavelength, the listener will detect more frequency or more wave per unit time. So what is happening here is that the wavelength is or becomes shorter. So more sound wave reach the listener per second. And the frequency increase. Okay, so that is what is happening here. Let's quickly mark that on. Wavelength is shorter. You have to say that as the car is moving or the source is approaching the listener, the wave becomes compressed. It is compressing the wave. That deals to a shorter wavelength. Therefore, more wave reach the listener per second. Let's just fix this word. I'm very, very sorry. Per second. And the frequency increase. Okay? That is what you have to say. More sound wave per second, which is the frequency. So there are the 2 marks. 1 mark for saying that the wavelength is shorter or the waves are being compressed, and then another one for saying more sound wave reach the listener per second or frequency increase, which is the same. So there is 2 marks for this one. Right? Let's go to the next question. Next question is 5.4. Now, 5.4 have to do with, they say, how will the answer in question 5.2 change if the police car is moving away? Well, if it's moving away, then it's not compressing the wave, it's now stretching the wave. The wave becomes longer, the wavelengths increase. And therefore, the frequency is less and is lower than. That is the answer here. Remember to ask a question in the comment if you don't understand anything. However, this is an easy topic that was well answered during the examination. All right. So 5.5 and then 5.5. Let's see what 5.5 says. Let's say the study of spectral line obtaining from various stars can provide valuable information about the movement of the star. The two diagrams shown represent different spectral lines of an element. Diagram 1 represents the spectrum of the element in the laboratory on Earth. Diagram 2 represents the spectrum of the same element from a distant star. Is the star moving towards or away? Now, this one is on Earth. This one is on Earth. This one is on a distant star. Now, what happened? If you compare, on this end you have blue, on this end you have a blue, and on this end you have red. So what happened to the spectral lines, to the lines? This line here, as well as this one here, and this one here. You can compare the first one and you see that the first line moved towards the right, as well as this one moved towards the right, and all of them move towards the red end of the spectrum. The red end of the spectra is the side of the spectra which have greater wavelength and a smaller frequency. So I have greater wavelength, smaller frequency. If thus it has a smaller frequency, that means that the star is moving away. So in this case, the answer is moving away. It is move away. How do we know that? Note, this is the spectral line. It doesn't mean that the star is red. The star is not red. The spectra move towards the red end. All right, which means is the shorter wavelength, the bigger wavelength, shorter frequency. All right, so the answer is moving away. There is a red shift. That is the answer. You can see a red shift, right? And there is 2 marks for that. The total is 10 marks. Right, so this is the question about a Doppler effect. I hope it's clear. If you have any question, please ask in the comment. You can ask questions, you can suggest anything. Once more, I recommend you always to answer the question before you watch the video. Thank you very much. Next time, or next question is on organic chemistry. Thank you. We'll see you next time.